Learn like a pro.
Have you ever really looked at a drop of black ink? You might think, well, it's just black. But what if I told you it's actually a secret cocktail of different colors all mixed together? So how in the world do you uncover what's hiding inside? Well, let's dive in. The secret is a surprisingly simple but really powerful technique called paper chromatography. Think of it as a scientific blueprint, a special map that lets us separate all those mixed up ingredients and see what we're really dealing with. You know, the easiest way to understand this is to imagine it's a big race. Let's call it the Great Separation Race. And just like any race, you need a racetrack, some runners, and of course, a few really important rules to make sure it's a fair competition. All right, so here's our setup. That special piece of paper, that's our racetrack. The liquid at the bottom, the solvent, well, that's kind of like the starting pistol that gets the whole race going. And the beaker, that's our stadium where all the action happens. Okay, now for golden rule number 1. This is crucial. The starting line has to be drawn in pencil, not a pen. Why? Because pencil lead, graphite, is insoluble. That's just a fancy way of saying it won't dissolve and run the race along with our ink. It keeps the starting line clean and fair. And this shows you exactly why that matters so much. If you used a pen, the ink in your starting line would just dissolve and smear all the way up the paper with your sample. It'd be a total mess and ruin the experiment. But the pencil line, it stays right where it's supposed to. And here's golden rule number 2, and it's all about placement. You've got to make sure the solvent level starts below that pencil line. If you don't, your ink sample will just wash away into a big puddle at the bottom before the race even gets a chance to begin. So the track is set. We know the rules. It is time for the main event. Let's get this race started and see how this incredible separation actually works. In every chromatography race, there are 2 key parts. First, you've got the mobile phase. That's our solvent, the liquid that moves, and it's what carries our ink up the paper. And then you have the stationary phase. You guessed it, that's the paper itself, the part that stays still. So here's how it all plays out, step by step. First, you prep your paper with the ink spot. Then you carefully dip it into the solvent. As that liquid starts to climb the paper, the separation begins. And in the end, you're left with your result, a finished chromatogram showing all the different colors. Now, here is the real secret to winning this race. Not all the colors run at the same speed. The substances that are more soluble, the ones that dissolve easily in the solvent, are like your Olympic sprinters. They just take off up the paper. The less soluble ones, they kind of lag behind. It's a race all about solubility. And the race is over. We've got our photo finish, but how do we actually read these results and figure out what we're looking at? Well, this is where a tiny little bit of math comes in to save the day. To figure out who's who, we calculate something called the retention factor, or just the RF value. Think of it like the official time or final score for each runner. It's a unique number that helps us identify each substance based on how far it managed to travel. And the calculation is super simple, I promise. You just divide the distance the color spot traveled by the total distance the solvent traveled. That's it. It gives you a number, your RF value, and that number will always be a decimal less than 1. So what do you do with that number? You play a little matching game. You compare your result to a chart of known values for different substances. So if our calculated RF value is 0.8, we just look at the chart and hey, it's a perfect match for red pigment. And just like that, one of our mystery runners is identified. Okay, separating colored inks is one thing. That's cool to see. But what happens when the things you're trying to separate are invisible? A lot of important substances, like amino acids, for example, are totally colorless. So how do you track them? This is where the science gets really clever. We use something called a locating agent. On the left, our finished race just looks like a blank piece of paper. But then you spray it with a chemical like ninhydrin or maybe shine a UV light on it, and bam, the invisible spots magically appear. It reveals the winners of the invisible race. So cool. So this might all seem like a pretty neat classroom experiment, but why does this race for purity, as we're calling it, actually matter in the real world? Well, you would be absolutely amazed at how much we rely on it. I mean, think about it. This simple technique is used in some really high-stakes situations. Forensic scientists use it to analyze evidence from crime scenes. Sports officials use it to test athletes for banned drugs. And it's used every single day in food safety to make sure what we're eating is pure and safe. Isn't that amazing? A process so simple you can do in a school lab is also powerful enough to solve crimes and protect our health. It really makes you wonder, If a simple piece of paper can reveal all of that, what other incredible secrets are just hiding all around us in plain sight, just waiting to be discovered?